So this is the Excel sheet that you'll be working with for this quiz. There's a download link for this Excel sheet in the quiz, so make sure you download this prior to watching the video. So what we'll be doing with this is plotting the data shown here, fitting a trend line to it, and getting an equation for that data. So what this data represents is width of paper in inches, and then how strong those various widths are as the width increases. So to do that, or to go ahead and plot the data, we'll highlight both columns. We'll go up to Insert. We'll hover over this button right here, click on it, and select a scatter plot. Before we do anything else, at this point, this graph is effectively useless because it has no axis labels and no title. So what we're going to do is add some labels to our axes and then change the title just so we know what the graph actually represents. So to do that, we're going to make sure the graph is selected. So make sure it's highlighted. Go up to Quick Layout. We're going to choose Layout 1, and we can see that when we do that, we get axis titles added to the graph. So now we'll come back to the graph. We're going to change these titles. So this is the y-axis. In this case, this corresponds to the tensile strength in pounds. So we're going to highlight it, delete the axis title, and replace it with tensile strength, and then put pounds. So we always want to put whatever units the axis corresponds to. We'll do the same thing on the bottom. Click on it, highlight it, delete that first title, change it to width in inches. So again, we want to make sure we're labeling our axis with whatever it corresponds to, and then whatever units corresponds to the data. We'll come over here to Series 1. Since we're only plotting one set of data at this point, not multiple sets of data, we'll go ahead and delete that, and we'll change the chart title to be widths of paper versus tensile strength. And so now we have a graph that says this is what we're looking at, this is what this axis is, and this is what this axis is. I'm going to make the graph a little bigger just to work with it. That's completely arbitrary. You do not have to do that. So now we have our data plotted. Before we spit our curve, we're just going to look at the data and get an idea of what it's doing. So these four sets of data that are effectively in a vertical line correspond to widths of paper of about 0.13 inches. These three dots here correspond to widths of paper of about 0.19 inches, and then these last three correspond to widths of paper of about 0.25 inches. So we can see that as the paper gets wider, the tensile strength increases. So we can see in general, there's a linear relationship going on here where as it gets wider, the strength gets bigger. So before we even go into the curve fitting, we have an idea that we should probably be looking at some kind of linear relationship for the curve fitting. So to do the curve fitting, I'm going to click on any of these data points just to select the data. So I'm going to click on this one. I'm going to right click and then add trend line. So we can see in Excel we have a bunch of options: exponential, linear, logarithmic, polynomial, power, moving average. So these are just a few options of curve fitting that you can work with. Outside of Excel, there's a far wider options with some heavier software that can do heavier curve fitting. Excel offers a good base level curve fitting approach, and that's what we'll work with here. Excel defaults to linear, and we're going to keep it at linear, but very quickly I'm going to select polynomial just to comment on the curve or the overfitting aspect that the quiz commented on. So I'm going to select polynomial. I'm going to change it to third order. And we see now that the curve looks like it goes through the data better. So if we go back to linear, we see that it follows the approach of getting wider and the strength going up. So we see here it's lower strength, higher strength, higher strength as the width goes bigger. But we may think, oh no, the line does not go through the data very well. There may be something wrong. So we say, let's try a polynomial. And we see, oh, now the line actually goes through the data. Is that a good thing? That may be a good thing in some cases, but in this case, when we know the data is going up as the width or the strength is getting stronger as the width increases, we can look at this and understand this is not the appropriate approach, because if we follow this line, we see right here it's roughly, again, 0.13 inches, because again, these four lines correspond to these four widths. So this is roughly 0.13 inches, and it gives us an approximate strength of about, let's say, 3.25 pounds. We follow this line down and it comes over here and it says at a width of about 0.16 inches, that gives us a strength of 0.5 pounds. That makes no sense for us because we know that as the width gets bigger, the strength should go up. And so there's no way for it to say, oh, 0.13 inches, 0.16 inches, this has a much, much lower strength. So that's just a very quick example of looking at it and saying the line may look like it fits the data better, but in reality, we're using our judgment to understand what the data actually represents. And we're saying in this case, the data should represent stronger strength as it gets wider. So again, that's just an example. So I'm going to go back to linear because again, we do not want to overfit and we want to understand what our data is doing. And linear does do what our data is doing. As the width gets wider, the strength goes up. So now we have a curve fit to our data. There's two things we need to do before we're done. The first thing is we do need to set an intercept because right now if we display the equation on the chart, so let's go ahead and display an equation. So this equation represents this line. So y is the tensile strength and x is the width in inches. We do need to think about that equation as well. So what we need to do is think about if we put in a value of 0 for x. So let's say the paper is 0 inches wide, which means it does not exist. We would still get a strength of 1.641 pounds because this is our y-intercept. So 1.7641 is our y-intercept. So 11.25 is our slope, x is our width, y is our strength, and this is our y-intercept. So with this equation, we're saying if we put in a value of 0 inches for the width, that paper that's non-existent would still hold 1.641 pounds because that again is what this equation gives us is tensile strength in pounds. So again, that's another judgment point. You need to think about what the equation represents. So in this case, we're going to click on the line again and we're going to go over here and we're going to choose to set an intercept. In this case, we're going to go ahead and put the intercept at 0 because when the width is 0, the strength is 0 because there's no strength there. There's nothing there. And again, that's very particular to your data. If you're working with a time series data where you're saying at time equals 0, there could be a value of y. So again, this is a thing where judgment comes into play. You need to think about what your data is doing. In this case, at x equals 0, there's no strength because there's no paper involved because it's saying this is 0 inches wide. So in this case, we're going to go ahead and set our intercept to be 0 because at 0 inches, there's 0 strength. And then we're going to display our equation on the chart. And so now we have this equation that allows us to approximate data based on our tested data. So now we have our tested data and we can approximate data and we'll be doing that in the quiz. So now this 20.201x, we can put in varies with the data and get approximations for the strength of the paper, which is what you'll be doing for a couple of questions in the quiz.